Dimensional analysis, U.S. Customary. So dimensional analysis is just the use of conversion rates which are always equal to 1. So what does that really mean? So we know that 3 feet is equal to 1 yard. Right, this is the same length. So that means they're equal. So what we do is we just put these over one another like this. So we can go 3 feet over 1 yard or 1 yard over 3 feet. And what does that mean? Well, it means that both of these things are equal to 1. So we're just multiplying something by 1 when we make it a conversion rate, like a conversion factor like this. So when we do that, that means we can then express either mass or a volume or a distance in a different way by using conversion rates. So let's do some examples. Example 1. Let's convert 2.1 miles to yards. So 1, you kind of have to go from a longer, this is going to be a little bit longer to get from miles to yards. So what do we know about miles, right? And we can look up our conversion sheet. So we know 1 mile is equal to 5,280 feet. Well, now we have feet because we are going for miles and we want to get to yards. So let's think about feet. Well, we know 3 feet is equal to 1 yard. So let's go ahead and see if we have enough conversion factors to get to yards from miles. So if we have 2.1 miles, we always start right with our starting amount, and we need to get to yards. So what happens is we want to use this conversion factor first because we want to get rid of miles. So how we get rid of miles is we put the mile on the bottom and we put the feet on the top. So we're just multiplying by 1, but this way we get rid of our units here. These cross out because miles over miles is just 1. So then we're left with feet, right? And so now we want to get rid of feet. So how do we get rid of feet? Well, we put feet on the bottom here. And then we could put yards on the top. So we know 3 feet is equal to 1 yard. Well, that means we can get rid of feet here, and we're left with yards on the top, which is exactly what we want. We want to have the N unit on the top. And then all we need to do is we multiply what's on the top, and then we're going to divide by what's on the bottom. So let's go ahead and just rewrite this. We have 2.1 times 5,280 times 1, which will just be whatever that is equal to, and 1 times 3 is 3. And this will be our answer. So we'll just get our calculators out. 2.1 times 5,280. 80 times 1, which will be itself. So we get 11,088. And now let's just divide by 3. And we get 3,696. And what's our units? It's yards. Now let's do another example. Example 2. How much bleach would you need in ounces to make a quart of a 5% bleach solution? So what do we know? This is kind of a question where maybe we don't know where to start, but we just need to kind of start thinking about a couple of things. So we know we probably have to do something with ounces, and we have to do something with a quart. Well, the end product is we need a quart. So we need a whole quart, and then instead of saying bleach solution, let's go B.S. So that's what that means. So we need a quart of this. What else do we know? Well, we need a 5% of this, right? So what does that mean, 5%? Well, if we go 5 over 100, that's also 5%, right? If we represent this into a fraction. So we need 5% of a bleach solution. So 5 over 100 is probably going to be something we need in this problem. And what's also something we know? Well, we also know we have 16 ounces, and that is equal to a quart. That's also represented as a quart, just QT. So let's go ahead and start writing this out. So we need to get rid of quarts. So let's go ahead and use this one first. And the reason why we're starting with this is because we need this as a final product, right? We need a quart of a 5% bleach solution. So let's go ahead and put 1 quart on the bottom because we need to get rid of quart. And then on the top we have 16 ounces of bleach solution. Then we need 5%, right? Well, 5% is 5 over 100. So let's just go ahead and use that. So this would be in ounces, and this would be in ounces. And this would be our bleach, because we only need 5 out of 100, which is like the whole solution, which kind of gets into a little bit more chemistry with dealing with solutions and making things. But we know how we can do this, because 5 over 100, so of a bleach over 100 is a 5%. So if the rest was water, you'd have a 5%. So now we've set up our whole problem. We have quart of bleach solution. So let's go ahead and cross things out. Let's cross this out. And what are we left with? We're left with just the numbers and our ounces of bleach. So that's perfect. So let's go ahead and rewrite this. We have 1 times 16 times 5 over 1 times 100. And then we get ounces of bleach this way. So let's go ahead and get our calculators out. We have 16 times 5 times 1 should be still 80. And then we're going to go ahead and divide by 100. And we get 0.8. So we need 0.8 ounces of bleach in order to get a whole, and then the rest of the quart would just be water. So that's what that means. So that's how we can make a 5% of a bleach solution. Now let's go ahead and do another example. Example 3. A baby weighs 9 pounds. How many ounces does the baby weigh? Well, in the last example, we saw ounces, right, used as, it's like the worst handwriting, but ounces used as, right, a volume. Like how much do we need of a certain thing? So that was measured in volume. Now we're dealing with weight. So ounces is a weird thing. It can either be a volume or it can be a weight. So in this example, it's weight. So let's go ahead and think what this is, this conversion. Well, 1 pound is equal to 16 ounces. So that's all we need. We need to go from pounds to ounces. So we only need to use this conversion. So let's go ahead and set this up. So we have 9 pounds, which is also LBS. That's also represented as pounds. Then we can put 16 ounces on the top because we want to end up with ounces. So we put that on the top, and then on the bottom we put the pounds because we want to cross this out. Right? These cross out, then we're left with just ounces, which is perfect. We want that on the top. So really what we need to do is go 9 times 16 over 1. And we get ounces. Now, let's actually do this in our heads, because I'm going to teach you a little trick here. So, write the trick. Well, 16 could be 10 and 6, right? So if we go ahead and go 9 times 10, we get 90, right? And then we go 9 times 6 because we need to have 16. 9 times 16. We can go 9 times 6, which is equal to 54. So when we do that, we just go ahead and add them up, right? 0 plus 4 is 4. 9 plus 5 is 14, which is 144 ounces. Now, I showed you this trick because it's kind of a cool mental trick. That's how some people actually do multiplication, is they make it into easier steps, like 9 times 10, so that's just 90. 9 times 6 is 54. Add it together, we get our total. So it's just a kind of a trick. Maybe we don't know, math could be more flexible. We don't have to go 9 times 16 and do in the long can or use our calculator. So it's just a different way to look at it.